When you design a database with Access, you often design tables that have relationships between them. Now this can help speed up your data entry. It can also enable the least amount of repetition, which would equate to the size and performance of your overall database. Now the relationships, if we look at an example, when you're planning a database, you make a list of all the fields that you want to have in your overall database. And we've got an example here. Maybe you sell products, and so you want to keep a list of your customer's name, address, their phone number, the invoice number, what quantity they purchased, the description and the price. Now the problem with this is that if we just created one table, then imagine a customer comes into your store, purchases an item, you then create a new record so you can print out an invoice for them, and you create a new record with their name, you get their address, their postcode, their phone number, you then fill in that they want one Sony widescreen TV at £1,000. That's saved, printed, and they go away happy. Now what happens when they come back the following day to buy a TV stand for their new television? You need to generate a new invoice, which means generate a new record. So you add a new record, you ask the customer for their name, their address, their postcode, their telephone number, and the details about their order. If that customer comes back the next day and the next day, you can see the issue we have here. We would be typing their name and address and their telephone number multiple times, which equates to more work for us and also storing much more information than what we need to. For example, if that customer buys from our store 50 times that year, we would have their same name and address detail over 50 times. So this is where relationships come in. You do a thing called normalization. You decide where you can split the table into smaller components. And what we have here, we've splitted our data into two tables. One table holds nothing but the name and address of our customers. The second table holds just the invoice detail. Now once you've created two tables like this, you then need to link them, and you link them by two common fields. Now an easy way of doing this, some people would just link the name and put a name field in the secondary table. The problem with that, if we link by their, for example, surname, their surname may be Jones, and we could sell items to many customers called Jones. In other words, that field is not unique, and it causes us problems further on down the line. So as denoted here, it would be much simpler to add a new field to each of our tables that contains a unique identifier for that customer. Now you will come across the properties of a table called a primary key, and this would be classed as a primary key. You link these, and then we talk about the type of link. There is a link called one-to-many. It's the most common link. The one side would be our customer's name and address, because in our overall database his name and address will appear only once in that table. However, that customer could have bought many items from us throughout the year, so there will be multiple orders for that customer. So this is called a one-to-many link. The one side is the customer table, the many side is the invoice table. Now we can do this again because we could have the same problem if we go back here. Instead of having this, if we just had this, you'll notice that if somebody buys a Sony widescreen TV, we would type that in the description and the price. But if another customer came along and bought the same TV, we would type Sony widescreen again and again. And every customer that bought that same TV from us that day, we would have to type that Sony widescreen description multiple times. So you think about breaking this down into a third table, as we see here. So now we give all of our products a product ID, and in my table that's shown in pink, this would hold nothing but the information about each of our products that we sell. And this is how relational databases work. It's a much more efficient way of working, but it does take some pre-planning. We are going to demonstrate how we create the relationships in our current example database.